Cerner Corporation. So I work on a team that we build personal health software, so it allows patients to kind of connect to their hospitals and kind of interact with their doctors. So one of the type of data we show is basically labs, procedures, problems. So we naturally have an interest of showing data visualizations with that. And one of the problems that we ran into when showing data visualizations, or trying to show any kind of charts, was we have to support a wide range of clients. So we have to support IE, we have to support a lot of mobile devices, and we have to support modern browsers, which aren't a problem. But the problem with supporting that wide range of devices and mainly user agents on the front end is the fact that we had to support IE, and supporting IE meant we had to use a lot of really crappy charting frameworks. So your options are extremely limited. You essentially have a handful, I'm sure if anyone's been in this problem, you have a handful of things like Flot and pie charts and a few others. Not very good. So one project that caught my eye was D3. So how many people in here are familiar with D3? A handful of you? Okay, so D3 is really cool. It's not a charting framework. It's more of like, it's probably a bad comparison, but I kind of like to compare it to jQuery for charts. It basically empowers you to do data-driven visualizations, and it gives you the tools you need to basically build any kind of data visualization you want. So these aren't chart components out of the box. This is just a demonstration of how you can use the D3 tooling to build anything you want. So this problem fit really well with what we wanted to achieve, in that it empowered us to build exactly what we needed to show patients. The problem with D3 is that it doesn't work with Internet Explorer. None of these visuals would open up. The reason for that is because it falls back, it relies on, it's a forward-looking tool set. It basically relies on modern standards, which IE doesn't support. Mainly ECMAScript 5 and SVG are the two large sticking points. So what I did, I created R2D3. So R2D3 is basically a patched version of D3. It's a shim. It's a shim for D3 that enables it to work in Internet Explorer. What does R2 mean in the D3 part? Well, R2 means raw file rendered data-driven documents. So raw file is basically just a very primitive, low-level vector graphic rendering layer that you can use to draw primitive shapes. He's got a lot of demonstrations here of how you can draw various things. It's really great for drawing simple things, but if you want to build out complex charts, the amount of code it would take would be very messy. So using this layer alone doesn't scale very well in a large team environment where you have a lot of people that need to build data visualizations. So I created R2D3. Sorry, I'm blowing up this. So I created R2D3, which basically lets you come in and all you have to do is you shim, you put in a conditional script blocks, you load R2D3, and if you're using a modern browser, you load D3. So the two are interchangeable. The beauty of this approach is that once you don't care about IE8 and lore, you can delete that scripting, conditional script include, and rely on D3. So it's kind of a progressive and graceful degradation approach, I guess. So we'll get into some demos. So I'm using IE VMs to load IE on my Mac. Every once in a while it just flat out crashes on me, so I'll head over here. Alright, so here's a few examples I made. This is using Chrome. So this is really simple stuff, but basically it's using various features of D3, including selections, rendering elements, rotations, such as right there, styling via CSS. So there's a bunch of different little charts you can draw. And then we have a more complex one here. This one morphs, and it's got a changing radius per slice depending on the value of the slice. The slice will change color, change position, and change outer radius. So come over and look at it via IE. You got the same visualization. It works just the same as it would in Chrome. There's bars. Here's your pi. And then now for the more complicated transitioning quartz example, there's that too. So the goal of this library was to make it easy for us to build charts, future looking, and also support users that are on older browsers until they transition off. So once they're off, we will rip out R2D3, the project will likely die, and then we'll continue going forward with D3. So pretty much what I got. I can go more technical if you guys want to hear more technical on how this works at a lower level. Otherwise, do you have any questions?
So I've never heard of D3, but I've heard of like fusion charts for just simple data visualization. I assume that with D3 you can do kind of the same thing that you do with Fusion plus the whole bubble and more.
I'm not super familiar with fusion charts. I can describe to you what D3 lets you do.
It's mostly Cartesian type plotting, and then you can do some you can't do the animated stuff like that or the non-contiguous examples that you're showing. But.
So D3 is broken up into a few core pieces of API. Let's see here. D3 is broken up into several components that make it very useful. The first one is the selections API. Now what the selections do, at first glance they appear to be very much like jQuery selectors in that you select elements and you act on them. The difference with D3 is D3 lets you select elements and then bind data to them. So looking at this code example, I'm on beta and they keep changing the view file browser. Right. So looking at this code example right here, the difference with D3 is, so I'm selecting all my arcs. My arcs are my pi slices. Can you guys see this? Probably, zoom in. Is that zoom in? Yeah, let me hide my file browser. Alright, so basically what you do is you select, the selector lets you select arcs. Well, at this point in the code, those arcs don't even exist. So you're essentially selecting nothing. And that sounds really weird, except for the fact that you bind data to it. So binding data to it actually forks off the selection into three parts. You have elements that are on the page that have data associated with them. You have data that you bound that doesn't have an element representation. And then you have elements that exist on the page that no longer have a data representation. And it lets you select those and do various things. So right here I'm selecting all elements that have data but don't have it representing the element on the page, and I append that element. And then to every element I transition it. So this is really powerful in that as my data set changes, I can rebind new data and I can instantly get control of elements that need to enter the page, elements that need to leave the page, and elements that need to be updated on the page. So that's one of the core pieces of D3. The other pieces of it are the transitions, is pretty nice, that's minor, is all tool sets. So they have tons of tools to work with arrays, tons of tools to work with math, colors. The colors change because I created a mapping, a linear scale that maps a numerical domain to a color range. And then you have basically all these different layouts you can do to render every type of chart you can imagine. So it's it's basically a giant tool belt that lets you build exactly what you want to build. So.
How well does it work on mobile clients, and is there anything that would work better on mobile?
So mobile with charts is a challenging problem. Basically, this R2D3 doesn't help you on mobile at all because it's mainly an IE shim. Mobile devices lately they have good support for SVG. Up until about a few years ago, Android was really terrible about it. I always thought it was funny that Android condemned Apple for not supporting Flash, when for how many years Apple or Android itself didn't implement the SVG spec in their operating system. So I was like, really, that's kind of double standard in my opinion. So older Android devices won't render SVG, so you're kind of out of luck there. You could fall back onto Canvas. D3 has examples where you can map this stuff over to Canvas. So essentially what D3 will give you is you give it it'll tell you how to draw a path on a line chart, and you could take that path information and then you could render it to a canvas if you wanted to. And I think Canvas has a little better support on mobile, but charting on mobile, especially intense charts, is kind of complex. On the iPhone, it'll work. It'll, like D3 will render fine on the iPhone for most visualizations. If you get the intense ones, they won't. But
so, what were some of the challenges that you faced when you were trying to make a shift with Raphael for this?
So I approached the problem in layers. I actually didn't even think it was going to be possible to get this far. Initially, all I wanted was access to the tool belt of D3. I had no hopes and dreams of using their selection API because I thought it wouldn't work. So I started with that, and R2D3 initially, when I first created the project, it was just a demonstration showing, hey, you include these ECMAScript 5 shims. Basically, you patch or put a whole bunch of prototypes on array, and you can work with D3. D3 will let you use its tool belt to, given a data set, given a point, it'll give you back a path, and you can feed that to raw file. So that's where it started. And then another guy took the project and he took it a step further, and he basically hacked D3 up and made it work basically with his own custom version. I liked his approach, and it showed that to do this was possible, but he hacked it a little more than I would have liked. So I basically took his approach and I took it a step further, and essentially what I did was I created a wrapper. I created a shell that looks like a DOM node, that has DOM node APIs, and I put it around raw file elements. In D3, all it is it's a layer. It's like jQuery. It's basically a layer around, and it's expecting to interact with the DOM node. So it interacts with my shell, and my shell then interacts with raw file. I also, one of the bigger challenges was actually getting R2D3 to read styles in the style sheet, because when people write styles, they apply them to SVG. And VML elements, if you ever looked at them, they're nothing like SVG. Not property names, not element names, nothing. So in order to achieve that, I basically create, for every element you intend to create with D3, I create a DOM node representation of it, and I create a raw file representation of it. Well, IE has this interesting property where if you create an element on the DOM, it automatically knows how to style it. So essentially, once I created the element, I was able to grab the current style off of that, and I could see how the user intended on styling that SVG. Exactly, class names, everything, hierarchy. So I could pull those styles off, and then basically I put them in preference order of, style overrides CSS, which overrides attributes, and then apply those appropriately with SVG defaults, and then I got the styling to work as well. So that's all. So.
Yeah, my name is Mike Overstreet. I don't know how much you've been involved in 3D printing, or how much you know about 3D printing. I mean, everybody knows about robotics, but 3D printing has opened up so much in the last 3 years. 3D printing has allowed people to do stuff they've never been able to do before, as far as price-wise. And one of my biggest hobbies is robotics. I like to play around with robots. I go to robo games and maker fairs and so on. So 3 years ago, when I was at the local hackerspace, everybody was playing around with 3D printers. And I was like, wow, these 3D printers are super cool. And I started thinking, I usually have to buy like a robot kit, or I have to do metalworking and so on. What if I take this 3D printer? Of course, right at that time, it was the cupcake, was really hard to use. But I was like, why can't I put the two together? Why can't I make a robot with 3D printing? And it's been a long and slow process over the last 3 years. As the printer's been getting better and better, and cheaper and easier to use, I started saying, well, I think I can actually make a robot now. So that's kind of how this project started. This is my version of the Darwin OP. It's an open software hardware platform developed by Virginia Tech. Its main purpose is RoboCup soccer and autonomous, actually 3-on-3 robot soccer, autonomous soccer. It's pretty cool. I got to see videos of it and stuff. But this guy is all 3D printed except for his servos. I'm having a little trouble with his OS right now because he's kind of unique in that most robots have basically Arduino-like controller, and they run the servos. He actually has a 5 PC in here with Linux OS, and he has a little operating system that runs on top of the Linux. For some reason it crashed on me, so he can't walk today. Hopefully, maybe like next time we'll have him walking. But I guess the big thing is to me is that the personal fabrication movement, it just opened up so many avenues, so many different things you could do that before, you had to go to an expensive machine shop, or you had to have somebody with a really high-end CNC machine, or you were talking about like a $20,000 dimension printer. But now with the replicator 1s and 2s and 2Xs, you're talking another $3,000. I printed most of his parts out using the up printer. It's about $1,500. I mean, the cost of personal fabrication is dropping so dramatically, and it's it just, I mean, to me the opportunities. I mean, part of the reason why I did this project is to show what you can do with it. To inspire other people to try to use the 3D printer to do whatever their project is. It's just not robotics, so that's kind of my spiel. But I mean, if you have any questions, like I said, hopefully I'll get it working next time.
How long did that take you to build? To build this pieces?
Once I started actually trying to 3D print these parts out, it took in solid about 3 months to print them all out. 3D printing has, like I said, has advanced a lot in the last 3 years, but there's still a lot of little things you got to play around with, because his parts were designed to be manufactured on using aluminum. So you had to kind of tweak stuff, and the cool thing is all the designs for the brackets were open source. You can just download them. I used Autodesk 123D and kind of modified some of the brackets. Some of them I had to make a little bit thicker. Sometimes when you're 3D printing, if your size of your walls are too thin, you got the nozzle has a certain width, and I'm trying to explain this, but as the nozzle has a certain width, if the width of the wall is in between nozzle widths of the extruder, you'll get like hollow spaces. So sometimes you have to increase the size, and then it's also the orientation. If you think about it, when you're laying down a 3D, I don't know if you've seen 3D printer in action. It basically lays down a layer upon layer upon layer. Just the orientation on the build platform of the part will increase or decrease the strength. Sometimes you'll have issues when it's printing out because of the layer height and so on. So just how the part is orientated on the build platform can change how it's printed or make it stronger or less stronger. So I just had to kind of play around with things and modify things to make them a little bit better, the parts.
So assuming you have a 3D printer at your disposal, what's the cost difference in printing it out with ABS plastic and purchasing a shell or a ready-made design or even molding it?
That's another good. That's a good point to bring up. If you bought a production version of the Darwin OP from Robotics, it's about $12,000. A lot of that is the servos. The servos, each servo here, he has 20 of them. It's about $200, about $220 a piece. But so I was able to manufacture it with all the parts, electronics kit, and everything. If you don't count the printer itself, all the printers I used, it was about $6,000. I saved myself about half off. Now, I mean, a lot of companies, I mean, depending on how much they're, you know, the markup and so on, you know, we're talking 30, 40, 50% and so on. But I did realize how difficult and time-consuming and tedious it is to assemble this guy. So you got to think that how many hours. I mean, I spent days and days tweaking and rebuilding and reprinting parts out. So when I'm trying to say when so you can see how $12,000 probably is a reasonable price for something that probably took man hours at least a day or two for a skilled technician to put together. So that's one of the cool things about that 3D printing allows you, is that you can download the design. You might even have to buy the design in the future, but you can download the design, modify it to what you want it to do, and then if you have access to or own a 3D printer, you can make your own parts and so on, and then it's just your time.
So since you're kind of pioneering this, did you take, now that you've perfected or mostly perfected your designs, have you uploaded them back to the community, or are you keeping them close?
I've not uploaded all of them, but I don't know if you know what Thingiverse is. I don't know if anybody have gone to Thingiverse. That's a great place to go. That's where it's a website that MakerBot owns and runs. But what people do is they upload the designs, basically their STL files. STL file is a really old file format. It's been around for like 30 years. But almost all your CNC machines and 3D printers use that file format. So what people do is that they upload their design to Thingiverse, so anybody can download it and use it, play around with it. The other cool thing a lot of people do with those is they do derivatives. They take a design and they say, well, I like that, but what if you did this or this, and then they upload their design, and then people upload their design, and they prove their design. It's a pretty cool process.
How hard is it to use like the software to do 3D modeling?
It's kind of, I don't know if you've seen some people that are really good at that. It's like an art. I mean, it just, a lot of time, there's a really steep learning curve on a lot of these software packages. Some are really expensive, like, I have some friends who have Inventor or SolidWorks, and they can do some really super awesome stuff on these software packages, but they're really expensive. Blender, but Blender has a really steep learning curve. I've seen people really struggle with Blender, and it may take them weeks before they can do simple things. I know that 3D, is it 3D DAZ? I think is another, yeah. Tim Middleton at the Hackerspace, just basically up the street up here, 63rd Brookside. He teaches classes on Saturday on different free software design programs. That's one of the bigger issues, because like I luckily was able to use 123D beta for a lot of this. Basically, it's that's Autodesk kind of scaled down free version of Inventor, but unfortunately. When they went from beta to what their new version that you can download, they changed it so much it's almost impossible to use now for just basic design work and stuff. I know I'm talking on and on about this, but it is 3D designing is very difficult. I've seen people. Yeah.
That's kind of still like the main challenge of getting into this space, and just learning how to use the.
I don't know if you know who Michael Curry is. He works for MakerBot now. He used to hang out here in Kansas City. He uses Google SketchUp, and I've tried to use Google SketchUp to do stuff, but I can't do anything close to where I've watched him, and within like a half hour to hour period, he can design super cool stuff using Google SketchUp. But he's been using it he studied in college, he's been using it for like 4 or 5 years, but he did wonderful stuff. The problem is, like I said, it's just the learning curve on some of these software packages is so difficult. Time consuming.
So what were you saying you were going to be using the robot for? Did you say playing soccer? Or did you give up?
Well, I'm going to use him just to play. The RoboCop soccer is a 3-on-3 soccer match.
Yeah.
I'm probably never going to be able to afford to have 3 or 4 Darwin OPs
Sure.
to compete in that. I wish I could, but I mean, like I said, altogether it's about $6,000 investment to put him together. So even though it's not $12,000, it still would be a lot for me to get 4.
Sure.
But my plan with him is I'm going to take him to Robo Games next month and try to compete in some autonomous events like a soccer event, a penalty soccer kick, and autonomous a dash and autonomous obstacle course. What we're trying with. But see, the cool thing about this guy, like we're trying to explain, separate from like most robots, is he just doesn't have a little Arduino-like microcontroller operating the servos. He actually has a Fit PC connected to the microcontroller, and the Fit PC actually does most of the work. It has a Linux Ubuntu on it. He actually has basically almost like a little robot operating system that runs everything. And it gives you all kinds of possibilities, autonomous capabilities. He has a camera that he can use for image detection, color. If you watch videos of the RoboCup soccer, they use the camera to see the outline of the goalposts. Then they can see that they have the ball is usually a red ball. He can actually walk up, see the ball, walk up to the ball, kick it, and try to kick it into the goal. Of course, a lot of that software is for the universities or for the people who have fine-tuned that software just for their team. But it's an extremely capable robot once you get it working.
So are these demonstrated online, like videos, or
Yeah.
you can cheer it on, or?
No, I didn't say it.
Yeah. Go out on YouTube and look up RoboCup. Like just 2012 and 2011, you'll see a lot of videos of Darwin, because the team Darwin won the kid size RoboCup gold medal for the last 2 years. So yeah, just go out on YouTube. There's all kinds of Darwin, and just Darwin OP videos.
All right.
I don't want to take up everybody's
Yeah, we got
time.
15 minutes left, so that's good. Thank you.
Yeah, no
Thanks
problem.
so much.
My name's David Stanley. I work for Intouch Solutions over in Corporate Woods. Those 2 projects were born out of ambition and a desire to do something better. Mine was born out of pure laziness, to be quite honest with you. I do web development, application development, mostly using PHP, MySQL, but I also do some Django, Python stuff with Postgres, and every once in a while somebody says, hey, give me something with SQLite, or this version of PHP, or that version of Django, or whatever. And I got tired of wrestling with MAMP on here and wrestling with homebrew and all the different environments. So I put together a Vagrant Chef script to start building up VMs using a virtual box. But I didn't want to build a VM for every different thing, a different script for every different thing, so I kind of cobbled this Frankenstein piece together and made kind of one script to rule them all, so to speak. And so what I got is, shrink this a little bit so you can see. So what I have essentially is this project out there that you can, my goal was to have one file where I could just change some values, run the build, and have it do everything else. So if you use Vagrant Chef at all, and I chose Chef because Amazon uses Chef and so does Rackspace, as opposed to using Puppet for a build. So essentially what you do is you come in here and you can pick your box. So this is running on Precise 32. I can pick 64 or any flavor of links that I want. It should work for the most part between Ubuntu and CentOS. There's some spots where it might not. I've been targeting Ubuntu specifically. You know, basically you go through and you give it your stuff, and right here is where everything happens. So you have to pick a Django app, or you change that and have it pick a PHP app. And I'll go through, put some defaults. So what's the name of the project, database user, password, name for the database, what's the server going to respond to with aliases. So the document root that the web server is going to point to, but maybe you want a working directory that the doc root is in, and maybe it's the same thing, maybe they're, you know, they're off. Pick your database, pick your web server. If you're using MySQL, I got the database seeding working, so you can provide a SQL file. When it runs the first time, not only does it create the user and everything, but it will seed the database for you with whatever's in that SQL file. And then if you're running it, again, trying to do a reload, and you already have it seeded and you don't want to reseed it, it'll do a check on on a table and say, hey, if the table's already there, then I don't need to do the seed at all. And then some defaults down here for MySQL, Postgres. List out what PHP packages you want. I also got a spot where I want to get to where I can say, pick this PHP version, or pick this version of Django, or pick this version of Python, have it go get me 2.6 and 1.4 and build it, and there you go. And so it all happens. The goal is to get everything in this one config file, so it would do everything for me. And if you go into the project, in this app directory right here, and everything is, these are all submodules. So the notion would be is you clone the repo, then clone your project as a submodule into that web root, so that you can go and do whatever you need to and push back just your module, not the whole thing and whatnot. But everything happens within this apps spot here. So if you pick Django, it's going to come in, it's going to set some defaults for you, and then this is my simple attempt at using Ruby, so it's all case statements, switch statements. So hey, if you're picking MySQL, install the server. This uses a Ruby gem to do all the interactions, so you don't have to write out bash scripts to do, you know, SQL statements at the command line. And then run right here. So this will do create your database, create your user, so on. Then this is where it does, hey, am I seeding it or not? But yeah, it does the same thing. Install the extensions. It's Postgres, SQLite. Your web server, depending on what you pick. It'll build it up. Not only will it build it up, but it'll also put the entire virtual host file in there with everything exactly where you want it. And so all your aliases and your path to your WSGI file can be all through there. So your WSGI script areas. Do that for Apache or Nginx. I was trying to get G-Unicorn working with it, but that was a cast iron pain in the butt to get the service to start and run. So I just finally said, screw that. If you're going to run it on Nginx, SSH into the box and just run manage pi, run server, and then Nginx will listen and start running. But yeah, and it's just installed a couple last little things, Python imaging, docutils, and then your Django version here. This would be really easy just to put a variable there and call it from the Vagrant file as a node. I just haven't done it. So what you get once you do that, so if you do a Django recipe, that's what you get. If you do a PHP recipe, you got a couple other cool little things in there too. Like I got Composer and Fing in there so you can run a build script right out of the project. And the build script for a PHP project comes with it. That was also born out of just pure laziness. I was tired of going, oh, I forgot to move those files too. So a Fing build script we use SVN at work. That'll go into SVN, tag the whole thing, run all your unit tests. If the tests don't pass, it does nothing else. So it starts off and it runs your test first, and then it'll go through and prepare. And so it'll make a tag, do everything in the SVN for you with that tag. And when you actually go to, it'll even build the documentation using PHP document. So it'll build all your API docs. I'd like to figure out a way that if PHP doc throws an error, I can have it stop and say, hey, you need to go back and fix your doc logs if your stuff isn't right. But you can, it even goes so far as on a deploy through the build script. We'll SSH into whatever your target is. We'll move everything there. We'll do a SQL migration through there with a dump file. And then instead of just overwriting your target, it'll create a symbolic link, move the symbolic link from the old build version to the new build version, so all your code is always version prod. But it's essentially just a virtual machine, right? So when you run your build script, you can see it goes through and cranks through all these different recipes, and you can tell where it's, it's building, like installing Flex and Bison and Git, our units going in. It's running Apache right here. Does a lot of stuff for Apache. Install, and you get done. There you go. It's this time 223 seconds to run it, so not too bad. I've seen it take 700 and some odd, depending on what package combination you have. Some take longer. Django seems like it takes a while to download and install. But then you just SSH into the thing and run it just like any other system, right? So you do. All right, make sure I'm here. So actually, I don't need to. This is Apache. It's already listening. So you can just go and if you use just put it in your host file. There you go. So now, no matter what your developers are working on, whether it's Windows, whether it's a Mac or a Linux box, everybody's dev environment is the exact same as production environment across everything. So pure laziness. I wanted one project to do everything, so I didn't have to deal with all the hassle. So a lot of stuff to do still, but it's up here if you want to take a look at it. Yeah, you can see. Well, one of my commits was screw G unicorns. So, but anyway, yeah, that's what I got. I've been hacking around on it. I think it's a lot of fun to just get something that just a couple little switches and doesn't give me this environment.
So you said this works on Amazon? So like if I started with a virtual machine, I could like do a build file?
Yeah, so Vagrant, this is running 1.05 as a version of Vagrant that I'm using, but 1.1 just came out, and it has a provider that will provision EC2 instances for you. You can also provision a Rackspace instance using Vagrant. And so essentially what you would do is in your Vagrant file, you could put in the parameters for your provider and say, hey, this is my EC2 key, this is blah, 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 blah. And so at the command line, instead of vagrant up, which starts and provisions your VM, you can say vagrant up dash dash provider equals EC2. And it will actually connect to your EC2 account and spin it up and use everything in your vagrant file and all the recipes that you're calling to build it. I don't know about you, but I like scaling like that. So.
Is there hooks to actually pull code from different repos?
Yeah, you can do anything you want through it. I mean, because it's all Ruby in these cookbooks, right?
Yeah.
So if I came in here, where's a good example of it? This one has a good example of it. So you can do, actually that's not an example I want to show. Here, you can execute bash commands right there. In an execute block or in a bash block. So you can, if I already have Git installed, I can either come in here in one of these and say, hey, git pull block or git init and then add a remote and pull. I can do that all through there if I want. My preference is I wanted this to be as agnostic of what the real project is other than settings. So I thought about putting a requirement in there that says, hey, if there's a requirements.txt, pip install those requirements on a Django project. But I'd rather keep that, I'd rather do that in the project itself, right? So I add a submodule, I pull the whole thing down, add a submodule, run it, and then I'd rather SSH in, do my pip requirements install. So as agnostic across projects as possible is kind of what I